Hello everyone. Today I am going to tell about complex numbers. The topics to be covered in this video are imaginary numbers, complex numbers, how to write imaginary numbers in the form of I, and how to write real numbers as complex numbers. We have already learned about these numbers. Those are natural numbers and whole numbers, integers, negative numbers and whole numbers are integers, and rational numbers. All these numbers are rational numbers, and also irrational numbers. Those numbers are root 2, root 3, root 5, etc. These numbers are called irrational numbers. And we have already learned real numbers include rational numbers as well as irrational numbers. All these numbers are real numbers. And have you ever seen these type of numbers? Root minus 1, root minus 2, root minus 4, root minus 7, etc. These type of numbers. Because in square root, we have learned that in the square root, there should not be a negative number. But in some quadratic equations, the solutions of some quadratic equations, we will get these type of numbers also. But we cannot find the solution for these type of numbers. So these numbers are called imaginary numbers. And the famous mathematician Euler introduced the symbol I for root minus 1. So you have to write now onwards root minus 1 as I. This is iota. I means iota. So I is equal to root minus 1. Therefore, I square is equal to square root of minus 1 whole square, that is minus 1. So from now onwards, you have to write root minus 1 as I. Now, I am going to tell you where do we see these type of imaginary numbers. If you see these examples, you will understand. For example, solve x square plus 1 is equal to 0. This is a quadratic equation. And here you have to solve the x values. So, x square is equal to minus 1. This you can write as x square is equal to minus 1. Therefore, x is equal to plus or minus square root of minus 1. Till now, we have learned that we cannot find the solution for this equation. But now, the Euler introduced root minus 1 as I, that is an imaginary number. So you can write the solutions of x as plus or minus I, because here root minus 1 is I. So plus or minus I. Therefore, the solution for this equation are x is equal to plus I or x is equal to negative I, that is minus I. So you can write like this. And if you see the next example, that is x square plus 2 is equal to minus 7. Therefore, x square is equal to minus 7 minus 2, that is minus 9. 7 minus 7 minus 2, that is minus 9. Therefore, x is equal to plus or minus square root of minus 9. Therefore, x is equal to, generally we have learned that it is we cannot find the solution for this because it is a negative number. In the square root, it is a negative number. But here, x is equal to plus or minus, you can write this as square root of 9 into minus 1. Because we know that square root of minus 1 is I. Therefore, you have to write like this. This is equal to plus or minus square root of 9 into square root of minus 1. That is, square root of 9 is 3. Therefore, plus or minus 3 and square root of minus 1 is I. Therefore, plus or minus 3i. Therefore, the solution for this equation are x is equal to plus 3i or x is equal to minus 3i. Now, how to write imaginary numbers in the form of I? Imaginary numbers are the numbers which are root minus 1, root minus 2, root minus 4, etc. These type of numbers are called imaginary numbers. The negative numbers in the square root. So those numbers are called imaginary numbers. And these numbers we can write in the form of I. We have learned that, just now we have learned that root minus 1 is equal to I. So the first example is root minus 1 we can write as I, and root minus 2 is equal to, root minus 2 is root 2 into minus 1. Minus 2 you can write as 2 into minus 1. Split this like this, and that is equal to root 2. Root of AB is root A into root B. So root A, that is root 2 into root minus 1. That is equal to root 2 into, here root minus 1 is I. So that is I. So square root of minus 2 is root 2i. And square root of minus 4. So this also you can write square root of 4 into square root of minus 1. That is square root of 4 is 2. So 2i. And next one is square root of minus 8. That is square root of 8 into square root of minus 1. Square root of 8 is 4 into 2. That is 2 square root of 2. So square root of 8 is 2 square root 2 into root minus 1. That is I. So this is the answer, 2 root 2 I. And if you see this case, this is different case. Square root of minus 2 into square root of minus 9 by 2. So first write square root of minus 2, you can write as square root of 2 into square root of minus 1, that is square root of 2i. You can see from here, this is square root of 2i, and here square root of minus 9 is 9 into I. 9 into I, square root of 9 into I, that is 3i. So this you can write as 3i by square root of 2. Now you can cancel square root 2 and square root of 2 here. And now you can see here 3 into I square. I into I, that is I square. 3I square. That is equal to 3 into I is root minus 1. Therefore, I square is, that is minus 1. So this value is minus 3. 3 into minus 1, that is minus 3. Now, I am going to tell what are complex numbers. The numbers which include real and imaginary numbers, those numbers are called complex numbers. So, the standard form of this complex number Z is equal to A plus IB. Here, AB are real numbers and I is root minus 1. This is an imaginary number, that is root minus 1. So, this is the standard form of complex number, and here A, this is a real number, so this is called real part. This you can denote as REZ. So real part of this complex number, that is A. And this is called imaginary part IB, because here this is imaginary number. You are multiplying the real number with the imaginary number, you will get the imaginary number only. So this is called imaginary part. So here the imaginary part you can write as IMZ. So this is imaginary part of the complex number, that is equal to IB. So here REZ is A and IMZ is IB. And you can see some examples of complex numbers. These are the examples: 3 plus 2i minus root 3 plus 5i, 9 minus root 7i. So here the real parts are 3 and here minus root 3 and 9. And the imaginary parts here are 2i, 5i and minus root 7i. And the set of complex numbers is denoted by capital C. And you can write in the set builder form like this: the complex number C is equal to A plus IB. This is the standard form of the complex number. So here AB belongs to R because AB are real numbers. So AB belongs to R. And we also know that all the complex numbers consist of real numbers. So here R is subset of C because all real numbers are in the complex numbers. Now, how to write real numbers as complex numbers? So we know that in the real numbers, there is no imaginary part, because if you see all the real numbers are 5 minus 2 root 5, 0, 2 by 3 and minus root 2. All these numbers are called real numbers. In those real numbers, there is no imaginary part. So you have to write this real number as a complex number like this. If you add the imaginary part, that is 0 into I, then you will get in this form, complex number form. So 5 is equal to 5 plus 0i and minus 2 is equal to minus 2 plus 0i. If you add this part, then there is no change in this number. So you have to add this part, imaginary part, like this. So you can write the real numbers as complex numbers like this. If in the complex number, the imaginary part is 0, then Z is equal to A. That means it is a real number. So it is called purely real complex number. And if it is 0, the real part is 0, then Z is equal to IB. So here it is called purely imaginary complex number. Now please do this practice questions.